on how it's made. Native healing drums. Raisins. Stereoscopic viewers. And ribbon microphones. For thousands of years, Aboriginal peoples have used drums to call on healing spirits. But the sound of the drum itself can be a source of renewal. The repetitive beat can induce a meditative state, which may actually have healing properties. Today, a new generation beats the drum to heal body and spirit. These young men are from the Tiwa tribe of northern New Mexico. Like their ancestors before them, they chant and drum in a rhythmic appeal to heal. To make a healing drum, they start with pieces of pine or spruce, softwoods that are lightweight. The native craftsman creates an octagonal design and leaves the glued joints to dry. The next craftsman soaks a cowhide in water to make it soft and pliable. He drapes the wet hide over a drum frame, and as he does, he looks for cuts or thin patches. He arranges it so that any flaws aren't apparent. He then trims the hide. This particular drum is for powwows, so it's extra large. It's a two-sided version for a deeper tone. He pulls the wet hide to the desired tension and punches holes in the skirting. He hammers nails through the holes to tack the hide to the frame and cuts a scalloped edge. He then tacks a hide to the other side. He places another piece of wet rawhide on a spiraled blade and pounds the hide into it using a hickory mallet. This slices the leather into a long, thin lace. He extracts the lace from the cutter. After softening it with water, he takes it outside. He wraps one end around a post and pulls, stretching the leather to remove slack. It breaks at any weak points, leaving the strongest parts. He now laces the leather drum heads to the frame. He cuts a slit in the end and pulls the rest of the lace through the slit to knot it to the drum head. He zigzags the lacing through alternate holes in the two drum head hides. He tugs the lace as he goes to pull the leather drum heads tightly to the frame. Once complete, he knots the other end. He threads the second piece of lace through the remaining holes, creating a crisscross pattern. Paint applied to the frame early on shows through the crisscross weave. The leather dries to a dark patina for a stunning contrast to the blue hue. This double-sided drum is now ready for a powwow. To make a single-sided healing drum, they bend a piece of wood into a complete circle. A craftsperson signs and stamps the maker's information on the inside. Then it's over to the drum maker. She pulls a wet hide to the wooden hoop and folds it under the rim, smoothing out any puckers. She punches holes for securing the drum head to the wooden hoop and slices off the excess hide. She's now ready to lace the drum head to the frame. She ties the skin to the frame in a configuration that looks like the spokes of a bicycle wheel. She pulls it tightly for the desired tonality. It's all in the technique. If she doesn't get it right now, the wet drum head will warp as it dries. The leather spokes meet at the center in a cross where the drummer will grip it. The leather darkens as it dries and the tension sets. She now weaves strips of tanned leather around the cross at the center. It's a decorative touch that also gives the drummer something more substantial to hold on to. The drummer will hook a thumb in the cross section to hold the drum with an open hand. An artist paints symbolic images on the native healing drum. She works freestyle. A few strokes of the brush produce a buffalo and then an entire herd. For native peoples of North America, the bison is a symbol of strength and unity. A corn maiden painting on a drum represents abundance. It's art designed to help one heal to the beat. People have been drying grapes to turn them into raisins for 2,000 years. Today, there are potato chips and chocolate bars, but people are still snacking on raisins. Preserved and sweetened by the drying process, they can be enjoyed anytime, anywhere. 2,000 years on the snack circuit, and raisins still get plenty of nibbles. They're also a popular ingredient in baked goods, cereals, and salads. At this California vineyard, they plant grapevine cuttings in late winter. They're the seedless kind. These cuttings take 3 years to grow and bear fruit. Each winter, they prune the vines, cutting away weaker canes and dead wood. Pruning reduces the number of buds, so the plant's energy goes to the ones that remain, resulting in larger fruit clusters. They twist the remaining shoots around an overhead wire trellis and tie them to it. Grapevines are natural climbers. Securing them to the trellis positions them to grow in an arc for maximum sun exposure. They pipe water between the rows. It pools there and seeps into the soil and down to the roots of the vines. These particular vines are growing on T-shaped trellises. It's an older style of trellis. When the grapes ripen, they cut the canes. The fruit continues to hang there, and it dries on the vines. After 6 to 8 weeks, the grapes shrivel up and become raisins. A harvester with comb-like teeth shakes the raisins from the vines. They fall onto a conveyor, and a vacuum pulls out leaves and then shoots the raisins into bins. On this particular harvester, the conveyor and the bins are on board. The T-trellises require a different harvesting system, and the bins are outside in the next row. Once full, a loader retrieves the bin, and then it's on its way to the packing plant. Upon arrival, these raisins undergo extensive scrutiny. An inspector from the American Department of Agriculture looks for defects as the raisins bounce by on a shaker conveyor. Technicians also test the moisture content and general quality of the fruit. A vacuum removes twigs and stems. They're lighter than the raisins, and so they can be easily pulled out. Here's a sample of the raisins as they arrive from the field, and here they are with the plant debris removed. They often store the raisins for weeks before further production, and during this time, the raisins stick together and form clumps. A revolving wheel with paddles now breaks up the clumps and separates the raisins. They tumble off the conveyor and onto a perforated shaker table. This separates any raisins which may still be clinging together. Some cap stems remain. These bits link the grapes to the vine stems. The raisins now flow into cone-shaped machines that spin them to knock off the cap stems without damaging the raisins. Once the raisins have been sorted by size, they travel under sprayers for a rinse, wash, and then another rinse. They cruise by a laser that detects any missed cap stems or plant material. A blast of air then gets rid of them. Next, the raisins go into an inspection station, and a worker picks out any material that may have been missed by the laser. With her approval, the raisins are ready for packaging. Suctioning devices grab and unfold snack-sized boxes and place them, lid up, on a high-speed conveyor. Raisins spill into the open snack boxes, and it's all a blur. They fill 30,000 snack boxes an hour at this facility. It takes about a year to grow and dry these raisins, and just minutes to package them. Stored in a cool, dry place, they will last for a year, unless someone eats them first. Stereoscopic viewers date back to the 1840s. Then, you had to manually insert one photograph at a time. In 1939, a new type of viewer was introduced, which used a reel of slides instead of printed photographs. You advanced from one to the next by pulling on a lever. Early stereoscopic viewers gave people a way to see the world. When viewers with reels came out, travel remained the focus. You could visit a tourist site, then buy yourself a reel at the gift shop as a souvenir. Today, 3D viewers are also a business tool. Companies use them as a creative way to market products or train employees. And consumers now buy them as a novelty or gift, going online to order custom reels featuring their personal photographs. Whatever the purpose, it's all about the pictures. The manufacturer can use photos shot with a 3D digital camera or with a standard digital camera. The company's editor transfers the photographs to a computer and types a caption for each one. If the photos were taken with a regular camera, he performs some computer magic. He moves the image backwards, away from the viewer's eyes, then floats the text in the foreground, closer to the viewer's eyes. This little trick makes the photo appear to be three-dimensional. He puts 2 of each photo on a reel template. You view one with each eye, and your brain combines the 2, creating three-dimensional depth. A photo and title in the center identify the reel. Then the editor sends the assembled reel file to the photo processing lab and sets up the number of copies to be printed. The photo processor's lasers print the photographs pixel by pixel on polyester film. The machine prints a full sheet of 35 reels in exactly 1 minute and 14 seconds. Then the sheet travels through a series of chemical baths and a dryer, and 11.5 minutes later, the film is ready. The editor carefully inspects every photo on every reel. If everything's perfect, he feeds the film through a laminator. The machine sandwiches the film between 2 sheets of transparent plastic, then uses simultaneous pressure and heat to fuse everything together. Encased in plastic, the floppy film is now rigid and 3 times thicker. They now feed the laminated film into a hydraulic punching machine. Its cookie-cutter type dies slice the perimeter of the reels, releasing them from the sheet. The viewer itself is made of injection-molded plastic. A worker secures the front part in an assembly fixture, then places plastic lenses in the eye holes. A machine then expands the plastic, locking in the lenses. Preparing 2 viewers at a time now, he places a frosted plastic panel on the back part to diffuse the daylight or artificial light coming into the viewer. An inner eyepiece goes over the diffuser. Then this machine applies heat to fuse it in place. Next, the lever you pull down to advance from photo to photo. This spring returns it to the up position after each pull. Now he mates the 2 parts of the viewer. A high-pressure air press squeezes them together in a permanent bond. The finishing touch? A printing pad stamps the front of the viewer with the brand name. Stereoscopic viewers have come a long way since their invention in the 1800s. While still offering a dose of nostalgia, there's a new twist: putting your very own photos on a reel as a unique gift or a fun way to relive those vacation memories. The ribbon microphone was invented in the 1920s and first commercially produced in 1931. It's called a ribbon microphone because inside, a thin aluminum ribbon positioned between 2 magnets converts sound waves into electrical signals. Introduced in 1931, ribbon microphones revolutionized the broadcasting and audio recording industries with unprecedented sound quality. This company manufactures a modern version of the RCA-44, one of the first ribbon microphones. This manufacturer handcrafts the microphone, starting with the frame, which holds all the components. After cutting a flat piece of brass, the machinist makes 2 bends with a press, then drills threaded holes for the fasteners, which will connect the frame to the rest of the microphone. He puts the bar into another press, which bends the 2 ends upward to form a U shape. The frame goes off to another department to be chrome-plated and polished. Meanwhile, another machinist takes a sheet of perforated brass to begin forming the microphone's signature grill. He secures it to a die with 2 mounting plates. The die is the shape of 1/2 of the multi-sided grill. He mounts it onto a fly press, a press operated by rotating a heavy counterweight. As that counterweight spins, the die descends into a forming mold that's also in the shape of half of the grill. A high-speed automated cutter trims the perimeter to make a neat, even edge all around. Then the grill halves are sent off to be chrome-plated and polished. Next, a technician assembles the motor, the heart of the microphone. First, he snaps on 2 strong magnets. The gap between them is where he'll later insert the key component, the thin aluminum ribbon, which gives this type of microphone its name. After aligning the top of the motor with the bottom, he attaches the frame, which has since acquired a custom-made transformer, electrical terminals, and side brackets. Now for that all-important ribbon. A technician crafts it from a hair-thin sheet of pure aluminum. It's so fragile, he has to handle it with tweezers. First, using the edge of a razor blade, he glues down the edges to a thin sheet of paper set on a glass cutting surface. Then he places a second sheet of paper on top, and with a razor blade, slices lengthwise, dividing it into 4 ribbons, each 4.5 millimeters wide. When sound waves pass through the microphone, they cause minute differences in air pressure between the front and back of the ribbon inside. This causes the ribbon to move in response to the peaks and valleys of the sound wave. The technician corrugates the ribbon so that it responds to these minute air pressure changes more accurately. He removes the protective papers and installs the ribbon in the motor between the 2 magnets. In this position, the moving ribbon is a conductor in a magnetic field, generating a tiny current, an electrical replica of the sound wave that can be recorded, amplified, or broadcasted. A technician tests the ribbon's tension to ensure it's neither too tight nor too loose. He hooks up the terminals to an audio signal generator and measures at what frequency the ribbon resonates. If necessary, he tunes the ribbon by adjusting its tension. He installs what's called a puff shield. It prevents puffs of air from stretching or tearing the delicate ribbon. A 2-part metal housing will encase the lower part of the motor. However, before assembling it, a technician glues on an embossed metal medallion bearing the company's logo. Then he takes the motor, which by now has acquired an output cable, stands it upside down, and assembles the housing around it. Then he turns it right side up and assembles the 2 halves of the grille. A sleek-looking chrome-plated band hides the joint. He fastens the microphone to a U-shaped stand called a yoke. On each side, there's a thumb nut, which you loosen to tilt the mic, then tighten to lock the position. Although newer technologies have emerged since, the classic ribbon microphone still remains a favorite of sound engineers around the world.